Motivating problem here is that when we have bushy binary trees, they're a great way to store elements with ordinal properties dynamically, like insertions and deletions. My example is supposing that I am opening a boba shop in the Bay Area. I want to order my boba drinks that I serve based on sweetness. How should I do that? So there are a couple of data structures that we're already familiar with. There's a hash map, but I wouldn't use a hash map since it would take O of n time to get the minimum, maximum, or median. And so hash maps in general, they're great for storing large amounts of elements. But when you want to know some sort of ordinal property about the set of elements, like the maximum or minimum, hash maps are generally not the right data structure for that. Another data structure that has some sort of ordering is a priority queue. I wouldn't use that either because it may get the min or max efficiently, but not the other one. So if it's a min PQ, then I wouldn't be able to get the maximum efficiently. If it's a max PQ, I wouldn't be able to get the minimum efficiently. So that's no good there. The simplest way that I can personally think of at the moment is to do this with a sorted array. Okay, yeah, a sorted array where my keys are levels of sweetness, and each of these levels of sweetness maps to an actual boba drink. Okay, that's what this picture is showing here. So each of these keys maps to some boba drink. So this looks good because I can easily get the minimum sweetness drink, the maximum sweetness drink, or the median sweetness drink like really fast, like constant time. However, I'm a new boba shop, so I'm gonna constantly be experimenting with my flavors by like adding or removing like different boba drinks. So the first problem is that, resorting my list every time I add a bunch of new drinks or take out a bunch of drinks, resorting may take around data and log n time depending on what algorithm I'm using to sort my list. The second problem is that arrays are of a fixed size. Notice I can't just add to an array if it's a fixed size. I would have to like double the size of the array for an example, and this might take around O of n time. Another great idea that we can use is a binary search tree. If the binary search tree is balanced, then getting the median will take constant time pretty much if it's perfectly balanced, because we know it'll just be the top element. Another example is getting the lowest element. We would just need to go to the very bottom of the tree, and if the tree is of height log n, then this will take log n. Same thing with the max. And with insertions and deletions, this will also be log n. If we were to add another drink of sweetness like 7, we could just add it here. So we would traverse down the list of log n and then just append it to the left child of 10. So this is only for perfectly balanced. Notice property would only hold if it's a balanced binary search tree. However, there are cases where we don't have a balanced structure, where it's a spindly tree instead of a bushy one. And so this is the case where we add the 10 first, then the 6, then a 5.5, and then all the way down to 1, so like in reverse order. And then the resulting tree will be of height n rather than height log n. And so when we try to find the minimum, for example, we have to traverse down the entire tree, which would take O of n time. So how do I ensure that a binary search tree is balanced? That's the motivating problem here.